Hello and welcome back to another episode of Beyond the Curve. Today we are going to unpack a really fun topic. It's all about simulation and modeling. And what gets me excited about this topic is that we get to tie in all of the other things we've been discussing with regards to audiophile, tuning, transducers, and more. So without further ado, let's jump right in. We've got two very special guests today. We're joined by Jarmo Kunka, who is our product manager in the audiophile portfolio, but also he brought along a friend, someone who's, I would consider a wizard in the audiophile world. We're here with Micah Faulhaber, who is an expert in simulation and modeling and works closely with Jarmo to help bring some of these products and solutions to market. Micah, could you give us a little insight about what you do for Sennheiser and what brought you here?
Hello. So actually, I'm coming from a somehow different topics. I was studying civil engineering back in the days, and but now I am with Sennheiser, with the brand Sennheiser for almost 10 years. And what I'm doing for Sennheiser is then I'm doing the full simulation models, starting with the transducers. It has 3 physics in it, but in the end, the transducer is located in a headphone, and we're doing the whole simulation, like from the transducers, very detailed, and then it is in the headphone, placed in the headphone, and it the transducer radiates the sound towards the ear, and we also we analyze the path from the transducer to the ear and what is actually then what is heard by the customer then. And so, but why are we doing the simulation models? It's if in the past it was always like if you have an idea to optimize a headphone, then it's always a pain to do it. Every prototype you make where you analyze your new ideas, it has to be built up, and it's a really hard stuff. So it's when I'm doing this detailed simulations, I can reduce the prototyping time a lot. So I have an optimized product, an optimized hearing experience within a shorter time by using computer simulation models, and yeah, that's what I'm doing for Sennheiser.
Jarmo, can you tell us how important this process is to you when bringing an idea into the real world?
Yeah, for me it is just for me it's super important, because in the end there's always an endless barrage of ideas that we have as a development team. So it's a list of dozens of ideas, and normally you just have to abandon like 90 of them immediately without even trying them if you were to really just try everything physically and really build like a physical transducer up and so on. So you need to really engineer an entire chassis, and you print it, and you need a certain magnetic cup that you have to engineer and build and so on, which is all very time consuming and expensive. And then it all needs to be really also precise. So if it isn't really precisely done, then you can also forget the test. It isn't representative. So it's a really time-consuming process. And the great thing about simulation is you can actually take all of these ideas, and if you have a fantastic simulation engineer like Micah, then she can actually do it super accurately. So it's really within dBs of the actual headphone, how it will sound. And you can actually go through all the dozens of ideas and see what works out and what doesn't. So this is really the only way for us to explore everything that we want to. And that is so important, because in the end, only by trying out, you find out the best solution. So it's always easy to think that you immediately get the best idea, and that will end in the headphone, and that will be the best headphone you can build. The reality is you always just have to try out stuff, because some things you think will be good will end up not working. And on the other hand, things that you think are sort of not so good ideas end up to be spectacular. So it's really invaluable actually to build something that you can at the end say, okay, this will be the best.
What are some of the what's some of the output that you are looking for when you're performing a simulation or a model of a new idea? I think a lot of us think of frequency response as the ultimate goal, but I I think there's more to it than that, right? What are some other metrics that you're looking for when you're modeling and simulating?
Actually, the frequency response is always our top goal and our top priority, but also by simulation. But we have also some other measures like THG, the distortion, or we have intermodulation, intermodulation. What is the English word?
Intermodulation, distortion.
Distortion, yes. So, but this is really hard to simulate. And in the end, if you're coming to nonlinear things, so where most of the actual physics is always nonlinear, but we're trying to keep it on a linear way, then it's more easy to simulate, and it gives us some hints to optimize for the optimization. But nevertheless, we have to go into the nonlinear region, and there we have mostly the THD as the distortion that we are looking in. Yeah.
And if I may just quickly build on that, so I think it's very easy to notice very fast that Maike is basically living a little bit on a different planet than the rest of the headphone enthusiasts, and in a very positive way. So whenever I'm talking with Maike, I'm always learning something. So that's why I'm really happy to have her here, because I probably learn a lot in this conversation. And I just want to tell a very quick anecdote. So a few months back, we had a meeting on a new damping material. And so the mechanical engineer also talked a little bit about it, and then Maike shot in with a question and asked, "Does it have an L?" And and that may seem like a perfectly reasonable question to some of you, but for most of you, you probably have a question mark in your face. Why would she ask whether something has an L? And that is basically the formula sign for inductivity in electronics, but also in acoustics. And what inductivity is that means that a high frequency signal is getting dampened. So like a 10 hertz signal would not get dampened and can just flow through freely. And if it's 10 kilohertz, it will be dampened by half or whatever metric it would be. And that is something when I joined the company, I probably wouldn't have understood at all. But when you are in discussions with Maike, then it always very quickly comes to these sort of things. So also to you, Eric, feel free to sort of dig in a little bit and ask if Maike says something like linearities and non-linearities, and some customers probably don't really know what she means. And I really appreciate it because it's really the science of it. And we are just sort of sticking transducers in headphones and headphone development, if you will. That's dumbing it down a little bit, but Maike is doing the real science.
I want to ask about where you are. We've been filming in this location, and it's very exciting to see all of the cool little gadgets and testing equipment behind you. Is this where you spend a lot of time, Maike, performing some of these simulations?
I'm not doing the simulations quite here because I'm living over there, and there is an office. In my office, I have big machines, computation machines, where I'm doing my simulations. But every simulation has to base on measurements, on really measurements that are precise and well thought about. And here is the area where we're doing the measurements, where the simulations are based on. And especially in our bag, this is my, it's so-called my baby, because we are, our team does this measurement of the diaphragm of our transducers with this baby. It's kind of worth $250,000, so it's really we are like touching is over. Don't break, but it's but we have here what we're doing with this laser interferometer is we are measuring the velocity of the diaphragm of the transducers, and that is always really important to have like an insight into the diaphragm, because we don't see it moving. So if you like you play music, sometimes you see the bass that the diaphragm is moving a little bit. You see it, but in the high frequencies where you have maybe 10 kilohertz, this is like 10,000 movement a second. It's not visible. You cannot see it. You have and even not so expensive lasers, they cannot measure these displacements or these velocities. So we have this quite expensive tool here over there, where you can measure the movement of the diaphragm over the whole frequency range, up to 20 kilohertz. And this is really, and this is so impressive. Then what's the diaphragm doing then? And only if you know what the diaphragm is doing, then you can try to optimize it. And then you can, via simulations, then try to optimize it, and then come again to the measurement and see what did your optimization really do to the product.
Can you simulate things beyond, say, driver size? Can you simulate driver geometry? Can you simulate magnet strength? Can you simulate the use of different materials?
Of course, yes. I'm doing the whole simulation chain. From we have like the magnet flux from the magnet inside the magnet gap. We can simulate that, and then this is electromagnetic simulations. Then we have the Lorentz force that is coming out of this magnet when the coil is placed inside the magnet, and this is then the electromagnetic simulations goes to the mechanic simulations of this coil of the diaphragm. So we have then mechanic simulations with different materials, how is the diaphragm moving then. And the third physics we have then is the acoustics, so the real acoustics, where the mechanic is then going into or radiating into the acoustic environment. And that is, so we can cover the whole chain of the transducer and headphone stuff with our simulations.
I got to imagine that you punch in different parameters, you're simulating different materials, and you do this all day, every day. I got to imagine you get to a point where you start to be able to almost predict what the end result will be. Have you ever worked on a project and been completely surprised by what the input was versus the output?
No, not only one time. This is daily business when you are really, when you have like a theory. This is always, but I think if you have in almost every was ist Wissenschaft?
Science.
In every science, when you have the theory, and then you want to prove it, and sometimes your theory is right, but sometimes it really surprises you, and that is what Guillermo mentioned some minutes ago, that we have this huge amount of ideas, and everybody says, the first, we have a priority list of maybe the first 5 ideas that they are worth try it. And then in our last project, I thought, no, maybe we start from the last point on the list, the maybe least probable, the least probable thing. We tried that because I have a feeling in my stomach. We have to try that, and that was in the end a really big thing for everyone. They made the product even better than we expected, and that was like I did not see that coming. So.
Which product was it? Can you give us a little? Is that something you can disclose?
Oh no. I don't think it's kind of
on the market.
It's kind of secret for now. Hopefully not too long.
But we'll tell you the details once it's on the market. We promise. And just to sort of bring the thread a little bit back to the headphone, because that is always the thing that Maike talks about, this very foundational scientific stuff, and then you sort of are really impressed by what she's saying, but then you forget, okay, how does it actually influence what I'm listening to? And a good example, so Maike just talked about these breakup modes that may occur at high frequencies with transducers, so which we can measure with these laser interferometers. My brother's actually working also on these machines, so that's a nice coincidence.
Oh, what's he doing?
He's actually a salesperson, but he's a learned physicist. So a very important part of headphones, for instance, is that the frequency response is very smooth if it is to sound natural, and the HC600 series is very, very popular for having really one of the smoothest frequency responses on the market to this day. And the core of that is actually this funny little transducer here. It's what we call internally the KDH580, and that means capsule dynamic headphone, basically. The special thing about it is that it was one of the first transducers in the world that was really computer optimized, now over 30 years ago. So back then the simulations took weeks and weeks and weeks. And back then they had to think about, okay, what sort of transducer movements correspond to maybe a break-in or distortion in the frequency response. And then they found out certain parameters that these break-up modes should only occur at certain frequencies, or they shouldn't overlap or something. And they were able to optimize this diaphragm for that. And so they didn't have to make so many trials that you couldn't make them in a normal project, and could really make this, to this day, still one of the most performant transducers in the day. So this is really physics basically at the limit. And this is something you can only do if you have this really, really incredible process of high performance simulation and then validation also with measurements.
And that transducer has been the jump off point for so many great audiophile products from that point on. So clearly the research is substantiated. We got some questions here from the community, and they tie right into this conversation. One question, and we get this was from YouTube, but we get this in the forums as well. Can one simulate the tube amplifier effect with software? And I think the broader question is, can you, through DSP, is it possible to, on the user side, not the development side, simulate the sound of different hi-fi equipment?
I mean, Werner would be a really good guy to ask it because he's our DSP engineer, but nonetheless, I can actually also give you an answer. So in a number of decades ago, so in the heydays of HiFi, when the very good digital amplifiers came out on the market, then there was a huge discussion whether they could ever become as good or high fidelity as the tube amplifiers. And back then there were then some challenges where some people measured the distortion profile of tube amplifiers, were able to program that on a digital amplifier, and dared somebody to tell the difference in a blind test. And usually people didn't take the challenge, let's say it like that. So in the end, I think this source, or generally this entire audio journey, is something very personal. So some people place different rates on the sources, like the amplifiers, the decks, maybe even the cables. We at Sennheiser are, of course, fans of headphones, so we place the most weight on that one. But in the end, it's your journey, and in the end, your brain is listening with it. So it's not just a measurement microphone or simulation that you are hearing. It is really your own experience. And if you have the feeling that you're improving the sound somehow, then by all means, go for it. Just because some measurements show something doesn't mean you should like it better or worse.
So we've got another question. It comes in the form of a statement from YouTube. And it is, if you're working on an HD 800S successor, something that would be really cool is bundling it with an EQ profile for that particular unit. And that would bring it closer to Sennheiser's in-house target tuning or sound. Do you see room in the industry for applying essentially testing measurements and simulations in the real world at the listener level?
So I will just defer to the question exactly what the user asked, because I think it's a really, really cool question. And that is essentially, should we just maybe apply a pre-EQ or something so that every headphone sounds the same, or give users an equalizer so that every headphone sounds the same and every channel and so on. And that is the norm for loudspeakers already for quite a while. So if you have a high quality loudspeaker like a Neumann or Genelec or whatever, then they will have the passive loudspeaker, which always have some variations because the transducers are never the same and the housing is never the same, and so on and so on. And so what they do, they measure the loudspeaker and then they apply an equalizer afterwards, save it in the loudspeaker, and afterwards everything sounds more or less the same. So the question is, why don't we do that with headphones? And one reason is a very practical one, that the head paddings, they change all the time. So first they change during usage all the time, and during compression they change the sound substantially. And then if you exchange to a different set of earpads, I mean, of course, if you change to a different set, then they will sound again different. So it's also a part that is just that has a lot of tolerances, and so you cannot just give out something that will work forever for that headphone. Nonetheless, the thought itself is very interesting, but in my opinion, it can only be really implemented once you have a lot of active circuitry in a headphone that actively measures all the time and applies correction all the time. And at some point we may do that, but that will probably not be in our high-end headphones within the next years.
Micah, when you're simulating the output, are you taking into consideration things like earpad compression over time and the natural use cycle of a headphone?
That's a really interesting question, because simulating the earpads is really a tough challenge. This is besides the transducer, it's the toughest thing you can do, like simulating that what you said, the compression, that even changing over time. That's a really hard thing. What we are not doing is the changing over time. What we try to do is the different compression things, when with people have different head sizes, and the compression of the ear cushion is then also different, of course. Yeah, but that's again, we are doing that not all the time. Just if we only if we have a really specific thing that we want to figure out, because that's for the general model, it's really complicated. So, yeah, but we started doing this some years ago.
I want to ask a question. We're going to put this question on screen, but I'm going to paraphrase it. The question was, about tonality and sound as it translates to height of a sound. If you're looking for a desired sound, let's say you want an audiophile headphone that has wide sound stage and tall instruments and great placement, is that something that can be simulated? Are there objectives that you're looking for in either the software or the methods?
The main topic of the simulation is just to give you measurable things like the frequency response, the THD curves, or like some other intermolation stuff. Yes, and other people then may übersetzen, translate this to this psychoacoustic things.
If I may just build on that, so I really like that answer, because it's sort of so Micah basically works backwards from the limitations of frequency response measurements. So that is what we talked about over the last episodes a lot, that frequency response measurement is really, really important, of course, to us as engineers, but it never tells the whole story. And the problem is, of course, that with these simulations, we are always limited to that. And so what we try to do is that from the outset of the project, we always try to find already, let's say, the environment in which we believe these effects, like a soundstage, will emerge in a superior way. So for instance, we will say that we want the headphone to be very open, and we want the transducer to be very angled, and we want the transducer to be as large as possible. And then we give all these constraints to Micah and tell her, and please now do a good frequency response on that.
Yes, and then I'm recreating a headphone prototype, and then we're giving it back to you, and then yes, with your really good hearing things, that what is that? Did we do a good job or a bad job? So, and then he was saying, no, it's kind of good, but this particular thing you can improve, and then give it back to me, and then we go again.
So I have a question, and Micah, I'm wondering, what is the balance of exploring new technologies from the research side versus optimizing some of the technologies we already have? I got to imagine you're doing a little bit of both, right?
Yeah, so what is the percentage of optimizing existing stuff or doing new stuff? I think it's almost even, because we always have to optimize the existing things, because we may have some things in existing products that we don't want to do again and maybe improve. And so I think, yes, it's almost even. And but I really like exploring the new stuff most because it's fun doing crazy things that Sennheiser did not do before.
And we did a lot of crazy things.
Crazy is good.
Yeah.
I want to pull in a question I got asked at a HeadFi meet over at CanJam. And the question was, is Sennheiser planning to utilize artificial intelligence in any way to explore or provide additional horsepower when performing simulations and modeling?
Artificial intelligence, like ChatGPT or something like this? No, I think we don't plan to do this quite now. I think the whole world is just kind of exploring what can you do with artificial intelligence. And now we have so many experts here that don't have to be replaced by computer stuff. And especially for the computer simulations, I don't see that in the near future that artificial or AI can replace the engineer or other stuff that is dealing with this really complicated topic, because acoustics is really quite some of the most complicated topics I experienced in my career. So when I have back in the days, I'm doing the civil engineering stuff, and this was sometimes most of it static and not dynamic. But if it comes to dynamic, if you have like waves going through different materials and having a lot of tolerances here and there, this is so complicated, and I don't see that artificial intelligence is coming to do the job. Maybe I'm wrong.
Yeah,
maybe
that's the stuff that nightmares are made of engineering students. But I would just build on it and say that a lot of artificial intelligence is built on existing data sets. So you feed a lot of data into something and hope that the computer sort of gets the gist of it. And the problem with acoustics is that we are at really, in terms of simulation, at the pinnacle of technology. So I have a bunch of people I know that have also connections to some larger audio companies having more than 50,000 employees. So fairly large corporations, and what they do is not nearly at the level as what Mike is doing. And so the problem is basically what sort of data do you want to feed it to actually learn on, because we are sort of doing the pinnacle thing. We don't have a million of simulations. We do some very, very high quality ones, but just by feeding a program like 5 high quality simulations, it doesn't get immediately very good at this extremely complex topic. So I also do not think that at this level, this will be a huge help in the near future.
Thank you so much for your insight in bringing us into your world. Thank you to the community for all these great questions. We look forward to going beyond the curve again with you in another episode, and we'll see you in the next one.